Okay, so this is 8th grade. This is lesson 2.6. They're talking about proportional relationships and slope. So I want you to copy this down here. Slope equals rise over run. You learned that recently. Which equals, and so here's an equation to find slope. And it looks really confusing right now, but you'll understand it here pretty quickly in just a few minutes. And these are not exponents, the 2 and the 1. You can see they're not in the top right corner of a variable. They're in the bottom right corner of a variable. And to calculate slope, it's y2 minus y1 over x2 minus x1. Okay, so I'll say it again. It's y2 minus y1 over x2 minus x1. Okay, you're going to have to memorize that. And
this isn't math anymore, it's letters.
Right, and that's called algebra. Abstract thinking. Okay, so, but it's all going to make sense here pretty soon. Okay, if you guys pay attention. So here's a line, and it's going through the origin. I didn't bother to label the x and the y axis. You guys should know what those are. This is the x-axis, and this is the y-axis. And so I just put 2 points right here, and this point is 250. Okay, and if you remember, I'm going to get a different colored pen here or something. I'll use this one. Remember, it's always x first and then y second. So this would be considered x, and this would be y. This would be x, and this would be y. Just, okay, I'm recording. Just take it and come set it over here. Thank you. So the 2 is x, the y is 50, the 6 is x, and the y is 50. Now, to calculate the slope, what you would do is you just simply plug in y2 minus y1 over x2 minus x1. Well, I'm just going to call this x1. So that's x1, and this is y1. And I'll call this x2, and this is y2. And now I'm just going to plug those in. So slope equals y2. Well, what number is y2?
150.
150. So I'm going to write slope equals 150. What am I subtracting? What's y1?
75.
It's 50. It's right there. Over, what's x2? 6. And what's x1? 2. Equals. So what's 150 subtracting 50?
100.
What's 6 subtracting 2?
4.
I know, I get it.
Okay.
That was division.
What's 100 over 4 equal?
25. Yeah. You're so smart. Thank you so much.
So the slope
Really good at math.
is equal to 25.
This is actually like
Okay.
simple. Okay.
Well, this is a simple example I'm giving you. They do get a little more complicated.
But it's the same principle.
But shh, this is a good example for you guys. And also I want to point out to you, and I mentioned this the other day, that whenever you have a line on a graph and it goes up from left to right, it is a positive slope. If you ever have a graph and the line goes down from left to right, let's say it goes like that, that would be a negative.
Oh.
a negative slope. Okay? So let's look at some of these examples here they give us. Looking at example 1. All right, Maya and her father are building a tree house. The roof will have a 9/12 pitch. That is, for every 12 inches of horizontal, in other words, that's left to right distance, the roof rises 9 inches. How can Maya determine the height of the roof at its peak? So here we have a run of 12 inches, and it's going up 9 inches. Well, it's 6 feet here, and every 12 inches it goes up 9. Well, 12 inches is, how much is that, Mr. Holmes, in a foot?
1.
That's 1 foot. So how many feet are in the 6 feet?
36 inches.
Can anybody tell me what that would be? Mr. Hendrick?
6 feet.
6 feet. So, okay. So there's going to be 6 feet in that, because in each foot it goes up 9 inches. And so they make a table here, vertical distance 9 inches, horizontal distance 12. And then if you double that, if it goes to 2 feet, it's going to be 18. 3 feet, it's going to be 27, and so forth. And you'd go all the way to 6 feet. And then they graph here, and they labeled the points. The first point down at the bottom here is the length in inches, or you could say the horizontal length, that's the x value, and the height in inches, that would be the vertical. So the very first point, it's 12 inches across. Go back to this, you can see it's 12 inches across. And then it goes up, how far? 9 inches. And if you look at the graph, sure enough, it goes up 9 inches, which would be right about there. And then they just keep going. And so it says the change in the vertical distance is the rise, and the change in the horizontal distance is the run. And you guys learned last week, or the other day, it's rise over run. All right? So the slope is the ratio of the rise over run. And so Maya can use the graph to find that the roof is 54 inches at the peak. 54 inches. So if they went over 6 feet, this point right here would be 54 inches. Circle to try it. I'm not worried about convince me. It says Jack graphs how far he plans to bike over a 3-day charity ride. Find the slope of the line. Okay. So it's rise over run. And so they did the graph here for us. What's the run? Let me pull a stick here. Miss Turner, what's the run in that graph? Can't hear you. No, the run is the horizontal distance going left to right. And so they did a little dotted line here. And so let me ask you again, what's the run in that? You know, you would think you would line it up and you'd think it's 3, but actually it's not. And this is what I want you guys to understand, because the run that we're trying to calculate goes from this point to this point. So how far is the run? What are we starting at? Where's the first point? It's 2. And then it goes to what? It goes to 3. So how far is the run? 1. Put a 1 right there. Okay? You guys see that? Now, what's the rise? Okay, we're going from here to here. So you wouldn't want to just say, oh, it's 90. because right here is where 90 is. Okay, we're going from here to here, so it's at 60, and it goes up to 70, 80, 90, and I heard somebody say it. It would be 30. So what's the slope of the line?
30.
Miss Durgan, is this line a positive or a negative slope?
Positive,
How do you know it's positive?
because it's going up.
It's going up from, you want to be able to clarify that, it's going up from left to right. Okay, good. Put up 100 points. All right, let's look at example 2. Let's find the slope of 2 points. Well, I showed you guys this earlier. We're calculating the slope, which is rise over run, and it's y2 minus y1 over x2 minus x1. And so in this one, let me pull a stick here. Mr. Dickerson is in here. Miss Lagarbo. Is this a positive or a negative slope? It is a negative slope, and that actually just threw me for a moment because they have that as being the origin, but it's a negative slope. Interesting the way they did that graph. So look at the y2 and the minus y1. So what's y2? They have these 2 points here. It looks like they're calling y2 a negative 800. It's going to be right there. Minus a negative 400. All right? So remember what you would do when you subtract negative numbers? So this would really be a negative 800. I'm going to change it to addition and change the sign of the number that follows, plus 400. And so a negative 800 plus 400 is a negative 400. And then down below, the x2 is 10, following the 10 straight down, minus 5, following that straight down. 10 minus 5 is 5, so we have a negative 400 being divided by 5, and you end up with a negative 80. And the slope is a negative 80.
Mr. Glazier, it's 0, 0, I think, because aren't all these graphs 4 graphs, and it's like 2?
What do you mean, aren't they all 4 graphs?
Is it the one we've been doing just like one part graph, and there's, you can continue and it's like the negative?
Oh, right, because graphs,
Aren't they doing a part of the graph?
yeah.
Because graphs look like that.
So this is what a full graph looks like. And this is quadrant 1. Okay, and this is primarily what we're dealing with. But this graph here is this quadrant. So the line's going like that. All right? Okay, look at example 3. Another rise over run, y2 minus y1 over x2 minus x1. And you can see what they're doing here. I think it's pretty straightforward. You guys should be able to do that by now. I do want to point out that when you guys calculate slope, and you use 2 points, it doesn't matter which points or coordinate pairs are x2 and x1 and y2 and y1. So somebody might calculate this as being x1 and this is y1 and this is x2 and this is y2. And then somebody else might look at this graph and say this is x1 and this is y1 and this is x2 and y2. It actually comes out the same. It doesn't matter. So when you're calculating slope between 2 points on a graph, it doesn't matter which 2 points you use and which ones you label as x1 and y1 and x2 and y2. All right, let's look at the triad at the bottom of the page here. It says the graph shows proportions of red and blue food coloring that the tailor mixes to make purple frosting. What is the slope of the line? And tell what it means in the problem situation. All right? So we have 2 points here. So I've got a 25 and a 35. So I'm going to write down 25, comma, 35. That's 1 point. And then I've got a 50 and a 70. And I'll label the 25 and the 35. I'll call that x1 and y1. And this can be x2 and y2. All right. Ms. Herrera, what's the formula to calculate slope?
Y2 minus x or y1. And then under it is x2 minus x1.
Okay. I'll stay with you, Ms. Herrera. So what's y2 in these points?
70.
Okay. So it's going to be 70 minus
35.
over
50.
minus.
25.
What's 70 minus 35? Over. Okay. So here we have a slope of 35 over 25. Can that be reduced? To what?
7/5.
Yep, 7/5, 7 over 5. So here's our slope. Our slope is 7 over 5. Now, what's the question? It says, tell me what it means in the problem situation. What's the 7 represent? It's the rise, right? Rise over run. But in terms of, look at the graph. What's the y represent? Red drops. So 7 red drops. And what's the 5?
Blue drops.
5 blue drops. Okay? So you'll have problems like this where you have to calculate the slope, and then they're going to ask you, well, what's that slope mean? But, they have no idea. Well, just look at your graph. What's the y value and the x value? No, or not value, but what do they represent? Okay? Question? Or okay. All right. Page 130. Question number 1 is the question, what is a slope? So I just underline slope is the measure of steepness of a line. And number 2, I already showed you guys these. How is the slope related to a unit rate? A slope is a unit rate when written with a run of 1. And number 3, why is the slope between any 2 points on a straight line always the same? Because it's a proportional relationship. Okay, circle 4, 5A and B. Next page, circle 6. So all of these are worth 1 point, those 4 boxes, and this box by itself is worth 1 point. Number 7, all of those boxes are worth 1 point. And then circle 8, 9, and 10. So quick question here. Looking at number 10 at the bottom of page 131, Miss Olson, is that a positive or a negative slope?
Negative.
It's a negative slope. So when they ask you to find the slope on a graph, one of the easiest things you can determine right away is if it's going to be positive or negative. So when you look at these 2 points, and they've labeled everything here for you, so it looks like the graph is in increments of 2. In other words, this is 2 and then 4 and then 6 and 8. And then same thing along the y-axis, 2 and then 4 and 6 and 8. And so here's your 2 points, okay? You'll have to label those. And remember, slope equals y2 minus y1 over x2 minus x1. It doesn't matter which one of these points you decide is well, no, don't want to phrase it that way. So, like, what are the coordinates of, let's say, this point here? This very first point. What do you think that would be? Take a look at it. What's the first value you list in a coordinate pair?
The x value.
The x value, okay? So here's the x. So here's 2 and 4 and 6 and 8. So what do you think that point would be as far as the x value?
-1.
I would say a -1.
Dang, what?
Because right here is 0, 0. If we're looking at the x value, it's going over just a little bit.
It's 2. No, it's because the
Right here is 2 if we went straight up from there. We're going this way and we're going straight up to this point. It's a -1.
okay.
All right, so what would be the y value?
-1.
2.
Looks like 2 to me. Okay? Let's look at this point. Mr. Holmes, what do you think the x value would be?
Oh no.
Okay. Miss Stevenson, what do you think the x value would be for this point? It's just going straight down right here. So what do you think would be right there? Would be Miss Stevenson. Okay, look up what I just did, hon. Here's the point we're trying to calculate the first value, the x value. So I'm going to go straight down from there to the x line. What do you think is right there? Yeah, I think it's probably 3. If this is 2 and this is 4 and it's right in between, it's going to be, well, actually not 3, but a what? A -3. All right. Mr. Holmes, back to you. Okay? Here's the point. Go over to the y value. What would it be? Miss Lagarbo, what would it be?
Wait, hold on. I got that. 6.
2, 4, 6. Yeah, it's going straight over to 6. Now, what I was going to say is it doesn't matter between which is x1 and y1 or x2 and y2. That doesn't matter. The slope will still come out the same. Okay? All right. 131, page 132. Circle 11, I want you to do A and B. 12, circle A, scratch out B. 13, not worried about. 14, do A and B. Okay. And that's it.